Now that we know how to find all of the asymptotes and holes of a rational function, we need to talk about how to graph them. So if you come upon a rational function and you're asked to graph it, first off, you know it's a rational function because there's a variable where? In the denominator. So the first thing you need to do is you need to find all of your asymptotes and holes. That's the very first step. Find all of your asymptotes and holes. You want to do that first?
Yes.
All right. Well, I can look at this problem right here, and I know it has a horizontal asymptote where? At y equals, not 1, but y equals 1, right? Okay, so there's a horizontal asymptote at y equals 1. Now I need to decide if it has any holes or vertical asymptotes. We do that by factoring the top and bottom.
Thank you.
And when we factor the top and bottom, we see that nothing cancels. That's good because that means I don't have, bless you, that I don't have a hole. But it's also bad because it means I have 2 vertical asymptotes. And that's kind of the worst case scenario. When you have more than 1 vertical asymptote, it makes a much more complicated graph. So that's bad. So we have vertical asymptotes at x equals -1 and at x equals +1. So we're going to have 2 vertical asymptotes and 1 horizontal asymptote. At this point, I guess I need to try to explain to you what asymptotes do to a graph. Basically, we know that the graph hugs asymptotes, right? But you need to start also thinking of them as dividing it into sections. So I'm going to go ahead and I'm going to put those asymptotes on and we're going to talk about them and let you look at them. If I put my horizontal asymptote on at y equals 1, I'm going to put it on as a dotted line or dashed. Then I'm going to put one on at x equals -1 and x equals +1. Ignore the horizontal asymptote for a minute. Vertical asymptotes divide the graph into sections. So this graph has 3 sections. It has a section here, and then it has the section that's between the 2 vertical asymptotes, and then it has the section to the right. So we call it left, middle, right. Do you guys understand that? Yes? Okay, so left, middle, right. Now what can happen out on the outside sections, out here, to the left and to the right, is a couple of things. Your curve could occur up here, or it could occur down here. And our job now is to figure out which. It has to curve and hug those 2 asymptotes. So it either will do it here, or it will do it here. So you have to figure out which way. The same is true over here. It will either go here, or it will come along this way. It can't do both. It's a function. It can only do one. It has to pass the vertical line test. So we have to figure out which one it does. Okay, y'all understand that? That's how you figure out the outsides. Now let's talk a minute about the inside. If you have 2 vertical asymptotes in between them, anything can happen. In fact, vertical asymptotes you can never touch, ever, never, never, but horizontals can actually get crossed over, which is like kind of stressful to people. But you can cross over a horizontal. But I will tell you that at your level, usually one of 4 things will happen between vertical asymptotes. In this midsection, you will either get an upward parabola, a downward parabola, an upward cubic, or a negative cubic. And it just depends. So what goes on in the middle is sort of like, that's the great question. That's the part that scares people. To figure out what's happening, you need to make a table for each section. So we're going to make a table for the left section. We're talking about that left section over there. Let's make a table, and let's pick some points to the left of this vertical asymptote right here. Give me some numbers. -4. Okay, something close to the asymptote. How about -2, -3, -4? Is that okay? -2, -3, -4?
Yeah.
Okay. -2, -3, -4. I want you guys to go use your table function on your calculator and give me those y values. We'll pause for a minute so that you can give me those y values. So everybody break out their calculator, type the function in, and go to the table and get the y values. What are they?
0.
0.
5/8.
Okay, give it to me as a decimal, guys. I don't do well graphing with fractions. 0.625. And how about -4? 0.8. Positive 0.8. Okay. Let's go put those 3 points on the graph and take a look at what's going on. -2, 0. -3, positive 0.625. And -4 is 0.8. Do y'all see how those points are getting close to that horizontal asymptote? Yes? Okay. And they're going to just keep getting closer. It may help some of you now to pick a point in between here. So tell me -1.5. Let's add that one on. Give me -1.5.
-1.4.
-1.4. Okay, let's go put that point on. -1.5 comma -1.4. So do you see how this one is now starting to hug this asymptote? So it just makes this little curve. And that takes care of the left section. The left section. Got it? It has to hug those asymptotes. Now, it can hug this way and up. It can hug this way and down. But it has to hug those asymptotes. So finding those ordered pairs is what tells you whether you're above or below that horizontal asymptote. Got it? Okay, now let's make a table for the middle section, the center. In the center, we talked about this. The center's kind of bad. And guys, by the way, this type of curve, the outside will always look like that. It could be up or down, but it's always going to look like that. It's always going to be that curve on the two outside edges. But in between asymptotes, vertical asymptotes, crazy things happen. Let's take a look. In the center, I need you to give me 3 or 4 points. It's going to be hard because they're all between -1 and 1.
0.5, 0.
Okay. You're going to do -0.5, 0, and 0.5? Okay. So we'll do -0.5, 0, 0.5. That may be enough. We may have to go back and do 0.25s as well. Okay. Go put those in your calculator and give me the y values that go with them.
5, 4, 5.
What is it?
5, 4, 5.
They're whole numbers?
Yes, ma'am.
5,
4,
4, 5. Okay. So there are our ordered pairs. Let's put those down over here and take a look at what shape they possibly can make. -0.5 is 5. Positive 0.5 is 5. And 0 is 4. And I told you that it will do one of 4 things. An upward parabola, downward parabola, an upward cubic, or a downward cubic. Which is this? It's probably an upward parabola. Tell me what the points are for 0.25 and -0.25.
4.2.
Huh?
4.2.
For both? What type of symmetry is that?
Yeah.
Looks like y-axis symmetry, doesn't it? Okay, so -0.25 is 4.2 and positive 0.25. Sure enough, it seems to be making a parabola there. We could even do -0.9 or -0.999, and you can see that it's just getting bigger. So we're just going to draw a parabola in here. So, Erica, that's what I was talking about when I said they behave very strangely in between. But for our basic purposes, what we're going to be doing, most of them will make a parabolic or a cubic shape in there. And guys, they have to hug those asymptotes. It can hug one up and one down, or it can hug both up or both down. But they have to hug the asymptotes in some way. Got it? Now we need to find some points for our right piece, and we will finally be done. So we need some stuff over to the right of x equals 1. So how about 1.5, 2, 3, and 4? Let's do those. 1.5, 2, 3, and 4. I'll pause for a second and let you guys get those ordered pairs for me. Okay, so if you substitute 1.5 in, you're telling me you get negative 1.4. What happens if I put 2 in? 0. What point is that? It has a name. A point where the y value is 0 is called an x-intercept because it lives on the x-axis. 3 gives us 0.625, and 4 gives us 0.8. Let's go put those dots on and take a look. 1.5, -1.4. Right there? 2, 0, 3.625, and 4.8. So it looks like this one also is in the bottom quadrant there. So you will find that rational functions, a lot of times they look like that on the outer edges. And if they have more than one vertical asymptote, they'll also have a midsection, which is kind of weird. Any questions about that? Let's try another. I think I'm going to break the recording here, though, because 10 minutes is kind of long.